In the last lecture, we talked about the truth functional connective conjunction. We gave the truth table for conjunction, and we showed how we could use the truth table for conjunction to figure out which inferences that use conjunction are valid and which inferences are not. Today, we're going to talk about the truth functional connective disjunction. We're going to give the truth table for disjunction, and we're going to show how we can use that truth table to figure out which inferences that use disjunction are valid and which are not. Now, in English, we usually express disjunction by using the word or. But the word or can be used in a couple different ways in English. For instance, suppose that Manchester is playing Barcelona tonight, and you ask me who's going to win. And I say, well, I have no idea who's going to win, but I can tell you this, it's going to be Manchester or Barcelona. Now, what I'm suggesting when I say it's going to be Manchester or Barcelona is that it's not going to be both. Manchester might win, Barcelona might win, but there's no possible way that both of them are going to win. Sometimes, in English, when you want to say that it's going to be one thing or the other, but not both, you say either or. Either Manchester is going to win or Barcelona is going to win. But sometimes when we use the word or, we mean it could be one or the other or both. So for instance, suppose you ask me what we should have for dinner tonight, and I say, well, we could have chicken or fish. Well, there's no suggestion that we couldn't have both. Maybe we could have a little bit of chicken and a little bit of fish. So it has to be chicken or fish or both. When I say chicken or fish, I'm not suggesting that it can't be both. Sometimes in English, we use the phrase and or to express that it could be one or the other or both. I'll say we could have the chicken and or the fish. The truth functional connective disjunction is expressed by the second meaning of or. It's expressed by the English phrase and or, where you mean it could be one or the other or both. That's what we're going to call disjunction in this class. Now, let's look at the truth table for disjunction. So let's look at the truth table for disjunction. Suppose you're using disjunction to combine the propositions we eat chicken and we eat fish into the disjunctive proposition we eat chicken or fish. Well, when is that disjunctive proposition going to be true? If it's true that we eat chicken and it's true that we eat fish, then it's going to be true that we eat chicken or fish. Because remember, when we use or here, we don't mean either or but not both. We mean and or. Could be one, could be the other, or could be both. So if it's true that we eat chicken and it's true that we eat fish, it's going to be true that we eat chicken or fish. Now suppose it's true that we eat chicken, but it's false that we eat fish. Well, then it's still going to be true that we eat chicken or fish. Suppose it's false that we eat chicken, but true that we eat fish. Then it's still going to be true that we eat chicken or fish. But suppose it's false that we eat chicken, and it's also false that we eat fish. Then is it going to be true that we eat chicken or fish? No, because we won't be eating either. So then it'll be false that we eat chicken or fish. This is the truth table for disjunction, and like the truth table that we saw for conjunction, it's going to work no matter what propositions we put into here, or here, or here. So, no matter what proposition you have right here, call it P1, and no matter what proposition you have right here, call it P2. When you use the truth functional connective disjunction to create a new proposition out of those two propositions, So you get a new proposition, P1 or P2. That new disjunctive proposition is going to be true whenever P1 is true, and it's also going to be true whenever P2 is true. So unlike conjunction, where you need both of the two ingredient propositions to be true in order for the conjunctive proposition to be true, in disjunction, you only need for one of the two ingredient propositions to be true in order for the disjunctive proposition to be true. The disjunctive proposition is false only when both of the two ingredient propositions are false. That's the only time a disjunction is false. So now, let me give you an example of how you can use the truth table for disjunction to show that a particular kind of argument is valid. We're going to discuss a kind of argument that is sometimes known as process of elimination. Here's how it goes. Suppose that you have to solve a murder mystery. Mr. Jones has been stabbed in his living room with a knife in the back. Now, you figure out that there were only two people in the house at the time of his stabbing, the butler and the accountant. You also know that the knife is positioned in Mr. Jones's back in such a way that he couldn't possibly have stabbed himself. So it had to be someone else. And whoever else it was, it had to be someone who was in the house at the time of the stabbing. So it could only have been the butler or the accountant, or maybe both. So, you know that the butler did it or the accountant did it. Now you find out that the accountant is a quadriplegic. So the accountant couldn't have stabbed Mr. Jones in the back. So now you know that the accountant didn't do it. And so, from the two premises, the butler did it or the accountant did it, and the accountant didn't do it, you can conclude the butler did it. Now, why is that argument valid? Here's why. Think about the truth table for disjunction again. So remember, the first premise, the butler did it or the accountant did it, is a disjunction. It's going to be true whenever one of its disjuncts is true. One of its ingredient propositions is true. So it's going to be true whenever the butler did it, and it's also going to be true whenever the accountant did it. But the second premise tells you that the accountant didn't do it. So the only way for the first premise to be true, given that the accountant didn't do it, is for the butler to have done it. And so you know, since the accountant couldn't have done it, that the only way for the disjunction, the butler did it or the accountant did it, to be true is for the butler to have done it. And that's why you can conclude the butler did it and your argument is valid. That's one example of a process of elimination argument. Of course, there are lots of others. But with all of those others, you can see why they're valid by looking at the truth table for disjunction. Remember how you can use the truth functional connective conjunction to build a new proposition out of not just two other propositions, but sometimes three other propositions. You can conjoin one proposition with a second and with a third. Well, you can do the same thing with disjunction. You can disjoin one proposition with a second and a third to create the proposition either this or that or the other or any combination of the three. What does the truth table for that look like? Here it is. The disjunctive proposition, P1 or P2 or P3, is going to be true whenever P1 is true. It's also going to be true whenever P2 is true. And it's also going to be true whenever P3 is true. In fact, the only time that P1 or P2 or P3, the only time that that disjunctive proposition is going to be false is when all three of the ingredient propositions are false. So here's what the truth table for P1 or P2 or P3 looks like. Now let's use the truth table for our triple disjunction to show how a particular process of elimination argument can be valid. Let's go back to our murder mystery in order to do that. Now suppose that you find out, contrary to what you had previously believed, the butler and the accountant were not the only people in the house at the time that Mr. Jones was stabbed. In addition, the maid was in the house and the cook was in the house. All right. Well, now you know that the butler or the maid or the cook did it. You don't yet know which of them did it, but you know that the butler or the maid or the cook did it. Now suppose that you find out that the maid and the cook, at the time of the stabbing, were off in the opposite corner of the house doing something else together. Well, now you know that the maid didn't do it, and you know that the cook didn't do it. So what can you conclude from those three premises? Premise 1, the butler or the maid or the cook did it. Premise 2, the maid didn't do it. And premise 3, the cook didn't do it. Well, let's use the truth table to figure this out. Premise 1 of the truth table tells you that the butler or the maid or the cook did it. So, the situation in which it's false that the butler or the maid or the cook did it, that situation is ruled out by premise 1. So premise 1 tells you that that situation is not the actual situation. Premise 2 tells you that the maid did not do it. So, any situation in which it's true that the maid did it is also not the actual situation. So, this situation is one in which it's true that the maid did it, so that's not the actual situation according to premise 2. This situation is one in which it's true that the maid did it, so that's not the actual situation according to premise 2. This situation is one in which it's true that the maid did it, so that's not the actual situation according to premise 2. And this situation is one in which it's true that the maid did it. So that's not the actual situation according to premise 2. Premise 3 tells you that the cook didn't do it. So that rules out any situation in which it's true that the cook did it. Well, here's a situation in which it's true that the cook did it. So that situation is ruled out by premise 3. And here's a situation in which it's true that the cook did it. So that situation is ruled out by premise 3. So premise 1 rules out this situation. Premise 2 rules out this, and this situation. And premise 3 rules out this, and this situation. Well, what's left? The only situation left that could be the actual situation is this one. See, because in this situation, it's true that the butler or the maid or the cook did it, just as premise 1 tells us. It's false that the maid did it, just as premise 2 tells us. And it's false that the cook did it, just as premise 3 tells us. But that's the situation in which it's true that the butler did it. So the conclusion that we can draw, based on the situations that are ruled out by premises 1, 2, and 3, is that the actual situation is this one, and in that actual situation it's true that the butler did it. So the butler did it. That's why the process of elimination reasoning that we just considered is valid. If premise 1 says the butler or the maid or the cook did it, premise 2 says the maid didn't do it, and premise 3 says the cook didn't do it, then by process of elimination, we can draw the valid conclusion that the butler did it. And this is why. Let me give you another example of how you can use the truth table for disjunction in order to show whether or not a process of elimination argument is valid. Suppose we know that Walter is a professional football player. Well, that means that he plays either American football, US football, or European football, which Americans call soccer, or Australian rules football. But now suppose we find out that Walter does not play American football. And you conclude from that that he must play European football. So, you argue as follows. Premise 1, Walter plays either American football or European football or Australian rules football. Premise 2, he does not play American football, and therefore, you conclude, he plays European football. Well, that argument is invalid, and we can use the truth table for disjunction to show why it's invalid. Look at this truth table. Premise 1, recall, is that Walter plays American or European or Australian rules football. So premise 1 rules out the situation in which it's false that Walter plays American or European or Australian rules football. And that's all it rules out. It just rules out the situation in which it's false that Walter plays any of those. Premise 2, Walter doesn't play American football. That rules out the situation in which it's true that Walter plays American football. So it rules out this situation, and it rules out this situation, and it rules out this situation, and it rules out this situation. So, premise 1 rules out the situation represented at the bottom. Premise 2 rules out the situations represented by these 4 columns at the top. So, can we conclude that Walter plays European football? No. He might play European football, but he might also play Australian rules football. Because look, all that premise 1 and premise 2 together rule out is these 5 situations. But there are still 3 situations that are possible. In one of them, Walter plays both European football and Australian rules football. In another one of them, Walter plays European football, but not Australian rules football. And in the third situation, that's left open by premises 1 and 2, it's false that Walter plays European football, but true that he plays Australian rules football. So based on the information that premises 1 and 2 give us, we cannot conclude that Walter plays European football. He might play Australian rules football instead. So the argument that you made is invalid. In the next lecture, we're going to consider a truth functional connective that's different from conjunction and disjunction in the following way. While conjunction and disjunction are connectives that can be used to build propositions out of 2 or more other propositions, negation, the connective that we'll talk about next time, is a connective that is used to build new propositions out of just one single other proposition. Negation, in other words, is a connective that you apply to one proposition to build a second proposition. And that's what we'll talk about next time. Now there's some exercises for you to do. These exercises test your understanding of the truth table for disjunction and of how the truth table for disjunction can be used to determine whether a particular argument that uses disjunction is a valid argument or not.